Hello friends, today's we learn the T flip-flop means toggle flip-flops, and this toggle flip-flop is made by the JK flip-flop. First of all, what is the meaning of the toggle? In this toggle conditions, if we apply any clock signals, in this clock signal we provide the output is 0, 1, 0, 1 and 0 in one clock cycle. So this condition is called the toggle condition. That means 0 or 1 represent many times in one clock cycle. This called the toggle conditions. In this toggle condition, in this toggle flip-flop, this is made by the JK flip-flop. Here J and K, this is called the JK flip-flop. If we connect these two inputs J or K with short, then this becomes the T flip-flop. In this T flip-flop, only for one input, either 0, either 1. If we apply T is equal to 0 input, if T is equal to 0 input, then J becomes the 0 and K becomes the 0. Here we apply the clock signal, so clock is become the 1. After then, if we assume Q is equal to 0, because in previous video we seen that the SR flip-flop's output is depend always the previous output of the flip-flop. So assume the previous output Q is equal to 0. So this Q is equal to 0. So that means Q bar is equal to 1. So Q is equal to 0 is passed on this. So K is equal to 0, 0, 1 and this Q bar is passed on the 1. Thus 1, 0, 1. So J input is 3 input 1, 0, 1. In the NAND gate, if any input is 0, then output is become always 1. In K, input is 1, 0, 0. That means 1, 0, 0. If any input in the NAND gate, the output is become the 1. In the previous lecture, we seen that in SR flip-flop, if both the input is 1, 1, so always we getting the no change conditions. So no change condition. So if both are 1, 1, assume Q is equal to 0. This means this Q is passed on and Q bar is equal to 1. This 1 is passed on. So 1, 1 means output is become the 0 and 0, 1 means output becomes the 1 in NAND gate. So here we see that if you here assume Q is equal to 0 and we getting also the output is also 0, means no change in the output of the Q is equal to 0. That means this called the no change condition. So in the T flip-flop, if T is equal to 0 input, then J is equal to 0 and K is equal to 0. So output is always no change. If we assume Q is equal to 1, then also output is Q bar is equal to 0 and output is Q is equal to of NAND gate also 1. That's when also become the no change. Now next, if you T is equal to 1 input, if we provide the T is equal to 1, then J also 1, K also 1, both clock is 1 and Q is equal to reference is 0, assume Q is equal to 0 and Q bar is equal to 1. So this Q is passed on here and this 1 is passed on here. So K input is 1, 1 and 0. If any input in NAND gate, the output is become the any input in NAND gate is 0, the output is become the 1. That means R is equal to 1. In this J, the 3 input 1, 1, 1. That means output is become the 1. Sorry, output is become the 0. If output is become the 0, then here the output is become the 1. If this Q is equal to 0 is passed on 0. If any input is 0, the output is always 1. As purpose 1 is equal to 0, this 0 is passed on. So in any input is 0, this output is become also 1. Another case, 1 is passed on in this, 1 is passed on in this, and 0 is passed on this. So output will given the q bar is equal to 1 and q is equal to 0. Another time we getting the assume 1, the output is become the 0. If assume 0, then output become the 1s. Means if t is equal to 1 and j is equal to 1 and k is equal to 1, so we getting always toggle condition, means output is 0 1 0 may be changed and q bar is also 1 0 1 change. Thank you so much for watching this video.